Imagine looking at a massive bonfire blazing on a distant hill, and then watching half of that fire suddenly vanish behind a coin held up in someone's fingers. That impossible shadow is falling across deep space at this very moment. A single mysterious body is sliding in front of distant stars, blocking out unbelievable amounts of light before disappearing back into total blackness. It is moving through the cosmic dark like an unseen hand covering a lantern. If you love exploring real space mysteries with solid science and no cheap hype, make sure to hit that subscribe button right now. Join our community of curious minds so you never miss another deep dive into the hidden corners of the universe. For hundreds of years, astronomers believed that starlight was steady, predictable, and simple. When people first pointed glass telescopes at the night sky in the 17th century, stars looked like permanent pinpricks of light stuck onto a giant dark canvas. Even as telescopes grew larger and camera sensors replaced human eyes, the basic rule remained the same. A normal star should shine with an even, reliable glow, fueled by the nuclear furnace burning deep inside its core. Whenever a star did change brightness, scientists had well-tested formulas to explain why. Some stars pulsate naturally, expanding and shrinking like a beating heart over several days or weeks. Other stars are locked in pairs, orbiting around each other so closely that one star briefly blocks the other from our view. These dips in light followed clean, perfect math that astronomers could calculate on a chalkboard. Everything changed when modern space telescopes launched into orbit around Earth. Instruments like the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, known as TESS, were built to stare at hundreds of thousands of stars at the exact same time. Their main job was to search for distant alien planets using a method called a transit. A transit is very simple to picture in your mind. Imagine a tiny fly buzzing across a bright street lamp down the road. You cannot see the tiny fly itself because it is too small and too dark. However, if you use a light sensor, you will notice the street lamp get just a fraction of a percent dimmer while the fly passes across the bulb. Once the fly moves past, the light jumps right back to normal. By measuring how much the starlight dips and how long the dip lasts, astronomers can calculate the exact size of the passing planet. A planet the size of Jupiter, which is 11 times wider than Earth, usually blocks only about 1% of its star's total light. A smaller rocky world like Earth blocks less than 1/100th of 1%. The light drops smoothly, stays flat at the bottom, and rises back up in a clean U-shaped curve. Every computer model predicted that transits would always look neat and symmetric. The physics seemed settled across decades of observation. Then, data began pouring in from deep space surveys that broke all the rules at once. Instead of a smooth, tiny 1% dip, sensors recorded wild, jagged drops in starlight that wiped out 10, 20, or even 50% of the star's total brightness. These drops did not look like neat U-shapes. They looked like messy, sharp saw blades on the graphs. Sometimes the light plunged abruptly in minutes, lingered in deep shadow for months, and then slowly struggled to recover. Even stranger, the dips did not always repeat on a regular schedule, suggesting that whatever was causing them was not a normal round planet traveling along a simple circular track. Astronomers initially thought the sensors were broken or that a cosmic ray had hit the telescope's digital camera. Yet when different telescopes on Earth turned toward the exact same coordinates, they confirmed the impossible truth. A gigantic, shadowy presence was moving directly across the star, casting an impossible silhouette across hundreds of light years of empty space. To understand why this discovery stunned researchers, look at the famous case of a star called KIC 8462852, located nearly 1,500 light-years away in the constellation Cygnus. When astronomers first examined the light measurements collected by the Kepler spacecraft between 2009 and 2013, they found dips unlike anything ever recorded in human history. At first, scientists assumed they were looking at an ordinary yellow-white star, roughly 1.5 times larger than our Sun. They expected the light output to stay flat with occasional tiny blips from orbiting worlds. Instead, in early 2011, the star's light plunged by 15% over the course of a single week. Then, 2 years later in 2013, the light dropped by a staggering 22%. To put that number in perspective, 22% means nearly a quarter of an entire star's light was completely blotted out. If you lined up every single planet, moon, asteroid, and comet in our entire solar system and paraded them in front of our Sun at the same time, they would block less than 2% of the Sun's light. An object that blocks 22% has to be monstrously huge, measuring millions of miles across. Yet it could not be a second star, because a second star would give off its own heat and light, which would easily show up on infrared cameras. It could not be a solid, rocky planet, because a planet that huge would have enough mass to pull the parent star back and forth violently. When scientists measured the star's gravity wobble, they found almost no movement at all. That meant whatever blocked the light was enormous in size, but surprisingly light in actual weight. The next clue came when researchers examined the color of the missing light. When a solid, opaque object like an asteroid or a planet blocks a star, it blocks all colors of light equally, whether red, blue, or yellow. But when specialized ground telescopes watched the star dim during a fresh event in 2017, they noticed that blue light was blocked, significantly more than red light. That single measurement changed everything. In physics, fine dust particles scatter blue light much more effectively than red light, just like smoke particles in Earth's atmosphere turn sunsets deep red. This proved beyond doubt that the giant shield was not a solid alien megastructure or a massive metal machine, as some wild rumors had suggested. Instead, it was an immense, sprawling cloud of microscopic dust particles moving together in space. However, that explanation immediately opened up an even deeper mystery that scientists struggled to answer. In the harsh environment of space, radiation pressure and solar wind from a hot star act like a giant cosmic leaf blower. The intense starlight should push fine dust particles away into deep space within a few hundred years at most. For that dust cloud to still be there blocking the light today, something must be actively creating fresh dust in massive quantities right now. Where could millions of tons of fresh dust come from every single year? The leading hypothesis suggested that a family of giant comets had been knocked out of their distant orbit and dragged close to the star. As these ice and rock bodies approached the star's blistering heat, they began to boil and disintegrate, trailing vast ribbons of dust behind them like enormous banners stretching across millions of miles. Another team of astrophysicists calculated that two small moons or dwarf planets might have smashed into each other at thousands of miles per hour. The violent impact would have pulverized both worlds into a swirling ring of debris. Over time, that ring of shattered rock would orbit the star, casting weird asymmetric shadows every time the thickest part of the cloud swung between the star and our line of sight. Astronomers also looked at the historical records of this same star, going back more than a century. By digging through old glass photographic plates taken at Harvard College Observatory between 1890 and 1989, researchers noticed an even stranger trend. Over the course of a whole century, the entire star had slowly and gradually faded by about 14%, completely separate from the sharp, sudden drops seen by modern satellites. This meant the star was undergoing two completely different dimming behaviors at the same time. It was slowly losing overall brightness over decades, while simultaneously experiencing violent, chaotic dips that lasted for several days or weeks. Computer models showed that a simple swarm of comets could not explain both phenomena at once. Scientists realized they were looking at a complex, dynamic environment where multiple cosmic forces were interacting in ways we have never witnessed in our own solar system. Have you ever looked up at the night sky and wondered what unseen objects might be floating between the stars right now? Take a second to leave a comment below with your wild guess about what this dark object could be, and tap that like button if you love a genuine cosmic puzzle. As astronomers searched the wider galaxy for similar anomalies, they realized this star was not alone. In fact, a much more extreme example was discovered around a young star called J1407, located about 450 light-years away in the constellation Centaurus. What researchers found there made previous light dips look tiny by comparison. Astronomers initially expected a young star to have a simple disk of gas around it, slowly forming baby planets over tens of millions of years. But in 2007, when the SuperWASP Sky Survey recorded the star's light, the brightness dropped by more than 95%. For nearly 2 months, this bright star was almost completely extinguished, flickering wildly with rapid changes in brightness that happened over just a few hours. When scientists modeled the light curve using supercomputers at Leiden Observatory in the Netherlands, they uncovered a structure so vast it defied belief. Passing in front of the star was an unseen companion world, likely a giant exoplanet or a failed star known as a brown dwarf. But this object was not traveling alone. It was surrounded by a system of more than 30 giant rings made of dust, pebbles, and ice. The total diameter of this ring system measures roughly 120 million kilometers, which is nearly 80 million miles across. That is almost 200 times wider than the rings of Saturn. If you replaced Saturn's rings with the rings of this mysterious object, they would appear many times larger than the full moon in our night sky, shining brightly enough to read a book by at midnight. Even more fascinating, the light measurements showed distinct gaps between the rings, where starlight suddenly beamed through unobstructed. In planetary science, a clean gap in a ring system almost always means one specific thing. A newborn moon is formed inside that gap, acting like a cosmic snowplow that sweeps up all the loose dust and rock along its path as it orbits. Scientists calculated that at least one of these newborn moons has a mass roughly equal to Earth, carving out a huge empty lane inside the ring disk. We are not just watching an object dim a star. We are watching the real-time birth of a whole moon system around an alien giant, frozen in a brief phase of planetary youth that lasts only a cosmic blink of an eye. The physics behind these rings also tells us about how our own solar system looked 4.5 billion years ago. When Jupiter and Saturn were young, They were surrounded by enormous disks of gas, ice, and crushed rock. Those ancient disks eventually condensed down to form the moons we see today, like Europa, Ganymede, Titan, and Enceladus. Observing J1447 is like looking through a cosmic time machine at the very infancy of planetary worlds. Astronomers are eagerly waiting for the next eclipse in the system, which is predicted to occur when the object completes its long elliptical orbit. When that happens, dozens of modern observatories across the globe will point their instruments at the star, measuring the rings in unprecedented detail to see how much the baby moons have grown over the past 2 decades. Yet these giant ringed systems only explain stars where the dimming happens around young, active star systems. What happens when the exact same strange dimming is discovered around dead, ancient white dwarf stars that should have gone quiet billions of years ago? That is the question that kept researchers awake when they turned the Hubble Space Telescope toward a dying white dwarf known as WD 1145-17, located 570 light-years away in the constellation Virgo. A white dwarf is the burned-out core of an old star, packed with as much mass as our Sun, but compressed into a ball no bigger than Earth. Astronomers expected this stellar graveyard to be completely still, quiet, and peaceful. Because the star is so dense and small, its surface gravity is hundreds of thousands of times stronger than Earth's. Any heavy elements or rocky debris that fall onto its surface should be pulled straight down into the core within days, leaving the outer atmosphere made of pure, clean hydrogen and helium. Instead, the light from WD 1145-17 showed erratic dips of up to 40% every 4.5 hours. The short time frame meant that whatever was blocking the light was orbiting just 500,000 miles from the white dwarf's blistering surface, which is barely twice the distance between Earth and our moon. The true nature of this rapid dimming turned out to be far more violent than a simple orbit. The extreme gravity of the white dwarf is actively tearing apart a small rocky planetoid, pulling chunks of stone and metal right out of its crust through overwhelming tidal forces. The intense heat of the white dwarf, exceeding 25,000 degrees Fahrenheit, is vaporizing the shattered pieces into trailing clouds of hot mineral gas and dust. As this shredded world races around its dying host star, it drags long, comet-like tails of rocky vapor behind it. Every 4.5 hours, these vapor tails sweep across the tiny white dwarf, plunging its light into darkness before racing around for another pass. Astronomers are watching a planetary autopsy happen in real time, witnessing the final death throes of a world being ground into fine powder and swallowed whole. This process revealed something profound about the chemistry of alien worlds. When scientists analyze the light passing through those dusty vapor clouds, they can read the chemical fingerprints of the destroyed planet. They have found high amounts of iron, magnesium, silicon, and oxygen, which are the exact same building blocks that make up the rocks, mountains, and continents on Earth. This shows that rocky planets throughout the Milky Way galaxy are built from the exact same raw materials as our home planet. The universe uses a universal recipe to cook up worlds with solid ground, iron cores, and silicate mantles. Yet it also shows the brutal fate that awaits almost every solar system when its parent star runs out of fuel. In about 5 billion years, our own sun will swell into a red giant star, swallowing Mercury, Venus, and possibly Earth, before shedding its outer layers and shrinking down into a small, hot white dwarf. The surviving outer planets, asteroids, and moons will have their orbits destabilized by the sudden loss of mass. Some of them will be flung inward toward the white dwarf, where they too will be torn apart into dusty rings and consumed piece by piece. If an alien astronomer thousands of light years away points a telescope toward our sun in the distant future, they might see our sun dimming erratically every few hours. They would be watching the pulverized remains of Mars, Jupiter's moons, or the asteroid belt casting long shadows across our dying star. Did you know that a dying star could actively tear apart and swallow entire rocky worlds right before our eyes? If that thought gives you chills, make sure you hit subscribe and join our channel so you never miss another mind-bending space breakdown. The story becomes even stranger when we look at massive red supergiant stars like Betelgeuse in the constellation Orion. Betelgeuse is a giant star so big that if you placed it in the center of our solar system, its outer surface would stretch all the way past the orbit of Jupiter. For hundreds of years, humans have watched this bright red point shine steadily in the winter sky. Then, late in 2019, something shocking happened that set the astronomical world on fire. Betelgeuse suddenly began to lose its brightness at a speed nobody had ever recorded. Over just a few short months, the star dropped to less than 40% of its normal brightness, fading so noticeably that people could see the change with their own naked eyes from their backyards. News headlines around the world began claiming that Betelgeuse was about to explode as a supernova. Scientists originally suspected that the core of the star had destabilized, or that a massive cold spot had opened up on its surface. The entire global astronomical community mobilized, pointing giant arrays of radio telescopes, optical observatories, and space telescopes directly at the fading giant. When the high-resolution images came back from the Very Large Telescope in the Atacama Desert of Chile, they showed something remarkable. The southern half of the star had completely disappeared into dark shadow, making the star look like an uneven, half-eaten sphere. The actual cause was discovered through careful computer modeling and ultraviolet data from the Hubble Space Telescope. Betelgeuse had coughed up a gigantic bubble of superheated gas from its surface, ejecting millions of tons of plasma out into space. As that gas bubble expanded and cooled down, the gas condensed into a colossal cloud of solid dust grains. Because the dust cloud was ejected directly along our line of sight toward Earth, it acted like a dark curtain hanging right in front of the star. It completely blocked the light from half of Betelgeuse's surface. By mid-2020, as the dust cloud dispersed into the wider vacuum of space, the star gradually returned to its normal fiery red glow. This event showed scientists that stars can create their own dimming shadows from within. A star does not always need an outside object to block its light. A violent burp from its own atmosphere can produce enough dust to blind our telescopes across hundreds of light years, creating a temporary cosmic eclipse born from the star's own dying breath. Astronomers refer to this phenomenon as a surface mass ejection, and it represents a completely new way of understanding how aging supergiant stars behave before they finally detonate. Instead of quietly burning through their nuclear fuel, these massive stars pulse with extreme violence, throwing off vast blankets of soot and dust that temporarily hide their true brightness from the rest of the galaxy. Yet there are other stars where the dimming is neither a burst of dust from the star itself nor a destroyed moon. In some systems, the dimming object is an entirely separate dark world with its own strange geometry. Take the mysterious case of EPIC 20437607, an innocent-looking red dwarf star discovered by the Kepler telescope during its second mission. In 2017, this small, quiet star experienced a massive, sudden 80% drop in brightness. The light plunged down rapidly over just one single day, but then took several days to slowly crawl back up to normal brightness. This steep drop and slow recovery created an asymmetric light curve that looks like a lopsided triangle on scientific charts. Scientists tried to fit every standard planet model to this event, but none of them worked. If a round planet passes in front of a star, the light drops at the same speed it recovers. A triangular dip means the leading edge of the passing object is razor-sharp and opaque, while the trailing edge is wide, diffuse, and semi-transparent. The most convincing model suggests that EPIC 20437607 was eclipsed by a massive tilted ring system surrounding an unseen giant planet on an eccentric orbit. As the tilted ring swept across the small red dwarf, the dense outer rim blocked the star instantly, while the thin inner rings let light filter through gradually as the planet moved away. What would you think if an unseen planet with gigantic tilted rings flew past our own sun and darkened daylight for a week? Drop your reaction in the comments below, and tap that like button to help spread real astronomy to more curious minds. Another extraordinary discovery came from a giant star known as VVV-WIT-08, located more than 25,000 light-years away near the dense center of our galaxy. The YT in its name stands for "What is this?", a label astronomers give to objects that completely defy existing classifications. In early 2012, this ancient giant star suddenly faded by 97% over the span of several weeks, turning almost completely invisible before taking another 100 days to return to its normal brightness. For nearly a decade, scientists analyzed the archival data, trying to understand what kind of object could blot out almost all the light from a star that is dozens of times larger than our sun. The data revealed that an unseen companion object surrounded by an enormous, completely opaque disk of cold dust had drifted across the star. Unlike the translucent rings of J1407, the disk around VVV-WIT-08 is so dense that almost zero starlight could penetrate through its central core. It moved like an enormous solid wall gliding through the deep cosmos. Scientists believe that this opaque disk is sustained by a hidden stellar corpse, such as a dormant neutron star or a compact stellar mass black hole, sitting silently at the center. As it pulls gas and dust from its wider environment, it builds a massive swirling accretion disk that remains dark and cold at its outer edges, creating a gigantic cosmic mask that hides everything behind it. However, the mystery of dimming objects does not stop at dying stars or giant ringed worlds orbiting within a solar system. In recent years, astronomers using powerful survey telescopes like the Vera C. Rubin Observatory in Chile and ground-based sky surveys have stumbled across a completely different class of objects that do not orbit any star at all. These are known as rogue objects, wandering silently through the cold darkness between the stars. A rogue planet is a world that was violently kicked out of its original solar system during the chaotic early years of planet formation. When several giant worlds fight for gravitational dominance around a young star, one of them often gets slingshotted out into deep space, doomed to wander forever without the warmth or light of any sun. Because these rogue worlds emit almost no light of their own, they are completely invisible to standard optical telescopes. They travel like dark ghosts through the interstellar vacuum. Yet they cannot hide their mass, and they cannot hide their gravity. When a dark rogue object passes directly between Earth and a distant background star, something extraordinary happens to the starlight. Instead of blocking the light, the rogue object's gravity acts like a giant curved magnifying glass in space. According to Albert Einstein's theory of general relativity, mass bends the fabric of space and time. When starlight passes near a massive object, the light rays get bent and focused toward Earth, causing the distant background star to suddenly flare up and become much brighter for several days or weeks. This phenomenon is called gravitational microlensing. Gravitational microlensing allows astronomers to weigh invisible dark objects that would otherwise remain completely hidden forever. By measuring exactly how bright the background star becomes and how long the brightening lasts, scientists can determine whether the passing body is a tiny free-floating moon, an Earth-sized rogue planet, or an unseen stellar mass black hole. Over the past decade, microlensing surveys like the optical gravitational lensing experiment, known as OGLE, have found evidence of hundreds of these free-floating worlds drifting through our galaxy. Some astrophysicists estimate that there may be more rogue planets wandering between the stars than there are regular stars in the entire Milky Way. That means trillions of dark, cold worlds are silently gliding through the cosmic night, occasionally casting shadows or bending light as they pass. Every time researchers believe they have cataloged all possible reasons for why a star might dim, the universe reveals a new mechanism that nobody anticipated. Consider the bizarre phenomenon known as a stellar eclipse by an unseen giant disk, seen in rare systems like Epsilon Aurigae. Epsilon Aurigae is a bright star visible to the naked eye in the northern sky. Every 27 years, like clockwork, this bright supergiant star loses half its brightness and stays dim for nearly 2 full years. For over a century, astronomers could not agree on what could possibly be large enough to eclipse a supergiant star for 700 days straight without producing any bright light of its own. The mystery was finally solved using a technique called optical interferometry, which combines light from multiple separate telescopes to create an image with the sharpness of a single giant lens hundreds of meters wide. In 2010, the Cara array in California captured the first direct silhouette of the eclipse in progress. The image revealed a colossal, flat disk of dark dust, measuring hundreds of millions of miles wide, cutting straight across the bright face of the supergiant star. At the exact center of this massive dark disk sits an unseen pair of small stars, orbiting each other while feeding on the surrounding dust like a spinning engine. The dust disk is so thick and cold that it completely hides the stars inside, acting as a massive cosmic blindfold that periodically eclipses the outer supergiant. Then there are objects so dark and massive that they do not just block light through dust, but swallow it entirely. These are isolated stellar mass black holes wandering alone through the galactic disk. When a massive star dies in a supernova explosion, its core collapses into an infinitely dense point from which nothing, not even light, can escape. If a black hole is not actively feeding on gas from a companion star, it produces zero radiation across any wavelength. It is completely pitch black against the black backdrop of space. For decades, astronomers knew that millions of these isolated black holes must exist in our galaxy, but had no way to find them because they are totally silent. In 2022, astronomers using data from the Hubble Space Telescope announced the first confirmed discovery of a lone, wandering black hole drifting through interstellar space about 5,000 light-years away. They spotted it because it drifted directly in front of a bright star in the galactic bulge. As the black hole passed, its intense gravitational field did 2 things at once. First, it magnified the background star's light for more than 200 days. Second, it physically shifted the apparent position of the background star in the sky by a tiny fraction of a milliarc second, like a funhouse mirror warping an image. By measuring that tiny wobble and the duration of the brightening, astronomers calculated that the dark object had a mass roughly 7 times greater than our sun, packed into an area smaller than a city. It was moving through our galaxy at nearly 100,000 miles per hour, kicked into high-speed motion by the uneven blast of the supernova that gave it birth millions of years ago. Are you amazed that scientists can detect an invisible black hole drifting completely alone in the dark just by tracking a tiny flicker of light? If this kind of real space detective work excites you, subscribe right now and hit the notification bell so you're always updated when new findings are released. These discoveries teach us a humbling lesson about the limits of our knowledge. When we look out at the night sky, our eyes naturally focus on the bright, glowing points of light. We tend to assume that the universe is made entirely of things that shine, burn, and radiate energy. But the truth is that the overwhelming majority of normal matter in the cosmos is cold, quiet, and dark. From vast interstellar dust lanes that stretch across entire spiral arms, to rogue planets wandering through empty space, to giant rings and disintegrating moons, dark objects outnumber shining stars by an immense margin. These hidden bodies shape the evolution of galaxies, provide the raw ingredients for future generations of solar systems, and hold the keys to understanding how planetary systems live, age, and die. Think about what this means for our understanding of our own place in the cosmos. We live on a tiny rocky world orbiting an ordinary yellow star, shielded by our atmosphere and sustained by a steady stream of sunlight that has remained stable for billions of years. It is easy to take that stability for granted and imagine that the universe is a static, unchanging backdrop. Yet the space just beyond our solar neighborhood is dynamic, restless, and filled with moving shadows. Dust clouds millions of miles wide are forming and dissipating. Distant planets are being ground to dust around dying stars. Rogue worlds are crossing the dark gulfs between solar systems, occasionally sliding across our line of sight and reminding us that there is far more hidden in the dark than revealed in the light. Every strange dip in starlight is an invitation to explore deeper. It is a signal that our current models are incomplete and that nature still holds surprises that challenge our best scientists. With the launch of next-generation observatories like the Roman Space Telescope and giant ground-based telescopes with 30-meter mirrors, we are on the verge of discovering thousands of new dimming objects across the galaxy. We may soon discover entire undiscovered classes of celestial bodies that we do not even have names for yet. We might find intricate alien ring systems around habitable worlds, or detect the faint infrared glow of planetary collisions happening in nearby star systems, opening brand new chapters in our understanding of planetary evolution. The cosmos is not an empty, silent void where nothing ever changes. It is a crowded, active theater where giant cosmic objects cast shadows across trillions of miles of space. By watching the light fade and return, human beings standing on a small blue rock are able to map the invisible architecture of the galaxy. If this journey into the hidden shadows of our universe sparked your curiosity, please make sure to subscribe to the channel, click the bell icon so you're notified the moment our next mystery drops, and leave a comment below answering this question. Which do you find more fascinating? Giant ringed worlds or rogue planets wandering in the dark? Be sure to share this with someone who loves uncovering the real secrets of deep space. Thank you so much for watching, and keep looking up into the night sky.